In the previous class, we were discussing on the contouring. In contouring part, we have seen what is contour. Then we have seen what are the characteristics of contours in the previous class. Now, in today's class, we will be concentrating our study on uses of contouring, then methods of contouring, then interpolation of contours and the contour gradient. If we complete this, we will be completing our module 5. Okay, so we will discuss in today's class regarding the contour uses, characteristics of methods of contouring, then interpolation of contours, and then along with the gradients of contour gradient. Now, in the uses of contour maps, right, there are we are going to have the 5 advantages by having the contour maps. We can have drawing of sections, then determination of intervisibility of points, then tracing of contour gradients in order to find the location of route, then measurement of drainage area, then the calculation of a reservoir capacity. So this we can have it by having your contour map. Okay, now from a given contour plan, the section along any direction can be drawn to know the general shape of the ground or the earthwork for the earthwork calculation. Okay, in order to suppose from a contour map is given to you, from that contour map we can have the section of this, and we can calculate the earthwork in order to find out the estimation that is going to be required in a one particular project. So this can be done with the help of your contour map. So this is your map, right? And here, as I have told in the last class, these numbers are nothing but it is going to give you the RLs, right? So in this from this particular your contour map, we can have the section on an x and a y axis, right? The points on which the line AB is going to be intersect. This is nothing but the line AB. It is going to be intersected. It is going to be with various contours are projected on a OX sheet. This is your O and this is your X, right? Here it is going to be plotted over here, and then their corresponding heights are plotted on OY. This is going to be plotted on a OX, and their corresponding heights is going to be RLC is going to be plotted on OY axis. Okay, then here now here we are going to have say 106. Here 106 RL is there, so it is going to be plotted over here. Now 106 it is plotted, and 105 it is going to be plotted. Here we are going to have these readings, and then we will be plotting over here. So then again 105 over here, 100 over here, 99 over here, 96 over here, and 97. Like this, if we are going to plot those RLs, we are going to get the shape of, or we are going to get the how the area is. Either it is going to have a slope, it is going to have the rising gradient, falling gradient, whatever might be the shape of that particular. In order to have the general shape of the particular ground, we can utilize the gradient or the contour map. This is how it is. Contour map is going to help us. Now suppose if indeterminate intervisibility of points are there, when we are going to have the triangulation stations are generally of these are of several kilometer, and usually they won't be having the intervisibility. So in order to have these, we use these different these contour maps in order to have the intervisibility. Now next point is tracing of contour gradients and the location of the route. Now a contour plan is going to be very much useful in locating your route for highways, railways, canal, or any other kind of communication line. Now here we are going to have the different gradient line, that is we are going to have the different contour line with having their RLs 100, 101, 2, 3, 4, 5, 6. Now these are not their RLs of that particular ground. It indicates that the height of those particular ground. See, 100 is lower than 101, 2 is lower than 101, 3 is lesser than 2. So the as the numbers are increasing, the height is also going to increase. So from these we can have in order to these contour grade lines is going to give you or it is going to tell you where we need to have the location of highways, railways and canal can be entertained. Now here now in this particular diagram, now A to B is going to have the upward gradient of 25 meter. Okay, 1 in 25. It is going to have an upward gradient that is going to be 1 in 25. Okay, now the contour are at an interval of 1 meter. This contour interval I have just in the previous class I have told you what is contour interval. The difference between the two contour lines we call it as an contour interval. So it is having a difference of 1 meter. So 101 minus 100. So it is 1 meter difference is there. The horizontal equivalent will be equal to 25. With A as a center, right? If we want to have the highway over here or if we want to locate any of the canals, if we with having the A as a center and with the radius which is going to representing as 25 meter, right? Draw an arc to cut the line of 101 RL of 101. So if we have 25 meter arc, right, then if we cut the 101 line, so we are going to get the point over here. Then similarly, by keeping again 25 meter from point 101 line, again on 102 we are going to cut an arc. So again with the same 2 to 3, again 25 meter, 3 to 4, again 25 meter. So we are going to cut an arc, and by this we can have the route from that particular area. So this is how your contour line or this is how the contour map is going to help us. Next is in order to have the measurement of a drainage area, right? The drainage area for a given point in a stream or a river, it can be calculated by using your contour plan. Okay, contour plan, it is the water, the source of all water that is going to be passed through the contour map can be plotted. Now the drainage area is going to have the following characteristics. Okay, it is going to often pass through the ridges. It passes every ridge or saddle that divides the drainage area from other area. It is always perpendicular to the contour line. As I was telling in the previous class that the drainage or contour line drainage lines are always the perpendicular to the contour lines. I was showing in the previous class. Now the next is uses is in order to have the calculation of a reservoir capacity. I will show you the diagram, then we can discuss regarding the reservoir capacity. This particular diagram, it is going to show you the contour map which is going to have some these 150, these are nothing but the RLs. 150 is written over here, 100 is written over here, and then you can see the dam which is present over here, again 100, and here we are having the least RL, right, there where the water can be stored. As 150 is above, right, 100 is again below, then again you can have these this shows you the contour map which is along with the RL. It shows that 150 is at a higher level, 100 is at a lower level, and then might be again here 90 or 80 some other RLs. You may get it from this particular diagram. Now from this particular diagram you can determine the capacity of a reservoir. Right, now in between how you can determine the capacity of a reservoir is I have told you, or we have discussed regarding the planimeter, how the planimeter is going to help in order to calculate the area. Now with having the planimeter, what we are going to do is we will be calculating the area which is going to have the 100 RL, right? We are going to calculate that particular area, then again 80 RL, then again 150 RL, right, 125, like that. Whatever the area that those particular RLs are covering, we are going to calculate those areas by planimeter, and finally by using your either by having the prismoidal rule or by having your your prismoidal rule or by having the trapezoidal formula, we can determine the capacity of a reservoir. Okay, so this is what we can do with, by having your contour maps. These are nothing but the different uses of the contour map. Now we will be discussing regarding the interpolation of the contours, that how the contours can be interpolated. Okay, so this is we are going to discuss now regarding the interpolation of the contours. Okay, this how we can do is, the contour interpolation of contours is nothing but it is an process of spacing the contour proportionately between the plotted ground points established by the indirect methods. Okay, here in this particular interpolation we are going to locate those contours, right, space those contours proportionately between the plotted ground points by the different indirect method. Okay, now here we can determine the contour interpolation can be done by the different methods. By the first is by the method of by estimation, and by having the arithmetic calculation, by having the graphical method. These are the different methods by how we can we can have the interpolation of contours. First, by the method of estimation. Now this method is extremely rough, okay, and it is used for the small scale work only. In the interpolation of contours, what we exactly do is we are going to space the contour proportionately between the plotted ground by the indirect method. Here we are going to actually, if suppose some area is given to you, and suppose some RLs has been given to you, in those RLs you need to fix up those contour line. For that reason we are going to have the contour interpolation. Okay, now the first method in by the method of estimation, this method is very extremely rough and it is used for only small scale work. Okay, the position of the contour points between the guide points are located by the method of estimation. Next is by arithmetic calculation. Now in this method is more accurate and it is more time consuming. The position of contour points between the guide points are located by the having the arithmetic calculation, right? Now here the grids will be given to you. Leave these contour lines, only you have taken these readings. Okay, now 608, here you are going to have these grid lines with having the RL 608, 617, 624, 633. Now in this grid line, if you want to have the your contour line where you have taken the reading, if you want to locate them, now what you are going to do is this, in these grid lines it is going to have the dimension of around, if you have plotted this in the your diagram, this AB, here you can see AB, this is going to have 1 inch, BC you are going to have 1 inch, now CD you are going to have 1 inch, now again DA is going to have 1 inch. Now in this plan, if you want to locate, for example, if you want to locate the grid line which is going to have the 610, okay, the difference between B and A you need to first calculate. Okay, now elevation difference between A and B, here what you want to do is, here you want to locate the gradient line, your contour line of 610. Okay, here you want to locate it. So what you are going to do, in order to locate this 610, you will be measuring the difference in elevation between A and B, because you want to draw a line between A and B. Okay, so what is how you can do it? The difference between B and A elevation is 617.3, which is present at B, and 67.4, right, which is present at A. This difference you are going to calculate. Here you are going to get it as 9.9 feet. Okay, this is 9.9 feet difference. Now the distance of 610 feet point, in order to calculate, now what you need to do is 610. What is the difference between 610 and 607.4? The difference is 206. So this gradient line, the difference in elevation 1 divided by 9.9 into 2.6, you are going to multiply. So 0.26 inch. Here now it was 1 inch, right? Here it was 1 inch difference was there. Now from A to B, it is, in order to draw the 610 line, you will be drawing it. It is having 0.25 inches from A. Now similarly, if you want to have the 615 line from the point A, what you are going to do? You will be having the difference in elevation between A and B, that is 9.9 feet, and the what is the difference between 617.3 and 607.4, right? It is 7.6. So you are multiplying it and you are going to draw it. So this is how you will be drawing having the arithmetic calculation, you can do the interpolation. So similarly from A to B you have done. Now with these two counterpoints may be located on A and B. Similarly, the position of the other counterpoints on the line AC, CD, right? AC, right? CD and BD, and also on AD and BC may be going to be located. Then by having the graphical method. Now next method is the graphical method. Here you are going to use these two graphs, by the first one and the second one, by having there are the different methods are there in first and the second. By using these two methods you are going to plot the graph. In the first method, it is on a piece of tracing paper, what your cloth and or the several lines you will be drawing parallelly with each other. Okay, with having the difference of around 0.2 meter interval, and if it is required, now what you are going to do is each fifth line you are going to draw it heavier to represent the meter interval. Now the bottom of the diagram is so prepared that the tracing of the cloth represent the elevation, right? It is going to represent the elevation, and the required points of it to be interpolated. These are the different the points that you need to have to interpolate. Now the values you are going to choose between the A and B, that is your 85, 89, like that you will be choosing, right? Then keep the tracing cloth on the line A on a line in such a way that the point A may lie on parallelly representing the elevation. Now rotate the tracing cloth and from on point B and lie parallel to the some distance, that is the point B is going to have the distance of around 98. So you are going to lie on it. The points at which the parallel representing your 80 your 80 you are going to draw it. Then similarly you are going to draw the second method, right? The second method is illustrated a line xy. This is your line xy. You are going to convenient length is going to be taken on a tracing cloth and sending it to the particular interval. Say you are going to have the interval of 0.2 meter on a perpendicular to the line xy. Okay, now what you are going to do is the interval between the point 2 and you are again in the intervals you are going to locate with having the highlighted lines. So again this is how you will be doing the in the second method. This is how the contour interpolation can be done. Now the contour gradient. Now what is contour gradient? A contour gradient is a line lying throughout on the surface of a ground, and it is going to be preserving a constant inclination to the horizontal. So this is how you are going to draw the contour gradient. So this is regarding your contour gradient. Now the next topic is the methods of locating the contours, that you can locate it by having the direct method as well as the indirect method. Direct method is going to have the two important points, that is by having the direct level and the staff, and by having the hand level. And then the indirect method is going to have the four methods, that is method of squares, method of cross sections, then plane table, and then the tachometric method. So these are the different methods that we are going to have.